Good morning, good afternoon, good day, whatever the time you're watching this. Welcome back to Through Inquisitive Kids. In this video, we will be starting our topic on the three properties of remainders, and this is going to be our lesson video. So this is a topic that I've covered very frequently, actually. I believe this is the third time I've been doing a topic about this, and the previous ones had all been basics. So I will be covering the three properties of remainders and plus an example of something else I'd like to include in this video. But if you feel like you need to go on to some basic problems first, I suggest you do that. And all you have to do is search up the keyword remainder/remainders in our YouTube channel, and I will be linking their links in the description down below as well. And you will come to, remainder word problems, working with remainders, etc. So let's get started with this topic. Okay, so the first thing I want to talk about is that, all right, I'm not used to writing fast yet. Okay, so we need to know that the sum of remainders is equal to the remainders of the sum. And I'll go over what each of these mean after I do the next one. So if we have the sum, of course we'll have difference. So the difference of remainder is equal to the remainder of difference. Okay, and our final one is going to be product. And our final one is going to be, of course, product of remainder is equal to, you guessed it, remainder of product. Now these seem really cool, right? It seems like it just flipped over, sort of, and I'll explain what they each mean. Let's first look at the first property, sum of remainders is equal to the remainder of sum. If you have, for example, 37 divided by 4, if you have, for example, 37 divided by 4, you'll get a quotient of 9 and a remainder of 1. If you take another number, for example, like 46 divided by 4, you know that the quotient is 11 and it has a remainder of 2. So notice that we have the same divisor here, but if you add the dividend, and in this case it would become 83, divide that by 4, and you will have 20, right? 4 times 20 is equal to 80, with a remainder of 3. And as you can see here, when we add up all of the dividends, the remainders from the previous two equations add up together as well. So we have our new remainder, which is 1 plus 2. And of course, if you somehow have 3 plus 2 and you get a 5, then 5 can't be the remainder because the remainder can never be equal to or greater than the divisor. So you could just subtract 4 from it until you had a number that was smaller than 4. So it would also have a remainder of 1 in that case. Same with the difference of remainders and remainders of difference, product of remainders and remainders of products. I'm not going to go into that, and if you would like me to talk about that, you could look at the links I have put in the description down below. Now let's move on to this example. What is the least possible value of a number that divided by 3 and has a remainder of 2, divided by 4 and has a remainder of 1? Of course, you could just go and find the number that you could first go on to all the multiples of 3, see if added by 2, just find numbers that go into these standards. Well, a quicker way will be, let's first call this least possible value, let's call it n. So n is equal to, all we have to do here is take the least common multiple least common multiple of each of the divisors. And in this case, it's 3 and 4. 3 times 4 and gets 12. So 12, and we'll have a small variable a here, plus, and then we add we add together the remainders and their divisors. So that would be 3 plus 2 is 5, but we can also get it from 4 and 1. And this works when you either have a common difference between the divisor and remainder, or you have the same sum. So here it's the same sum, so it would be plus 5. But of course, if you had subtraction, then you would subtract. So let me ask you, in order for n to be a positive integer, what is the least value of a? So you might see 1, right? A is equal to 1. 1 times 12 plus 5 is 17. But would there be a better value for a that makes this even smaller? Right, I only said that n could be a positive integer. I never said that a had to be a positive integer. Of course, it had to be an integer, but positive? I don't think so. So if a is equal to 0, and we substitute the value of a into here, 12 times 0 is 0. 0 plus 5 is 5. So n would equal 5. So the least possible value for n is 5. And of course, if for some reason this constant value was greater than this, than the coefficient here, you can even go into negatives. So that's something that you could do. So thank you for watching through Inquisitive Kids, and I'll see you in problem 1.